Hello everyone, and welcome to today's chem lesson. Today we are going to take our crisscross method and do it in reverse. We're going to look at how we go from the name of a compound to the formula for that compound. And while this might sound like just taking the steps of the crisscross method and just flipping them, it's actually, believe it or not, a little bit easier than that. On the screen in front of us, we have the exact steps of the crisscross method exactly as we've been using them throughout the last couple of videos. Alright, first we assign our ones, then we crisscross. First ion is always positive, second ion is always negative. Then we check our periodic table, and finally we get the name. Now, when we start with the name, we want the formula. We're not going to do the steps that get us from formula to name. We're going to do pretty much the reverse. And so let's take these steps and turn them backwards. This is a little better, right? We've taken the steps to the crisscross method, and now instead of writing them from top to bottom, we're writing from bottom to top. We're flipping them to do the inverse. We're doing the reverse of what we have been doing. But some of these are not going to stay the same. Right? We're not going to get our name. We already have our name. And so we're going to readjust some of these steps. We're going to change them up to make a easier thing to follow to go from name to formula. So the steps that we're actually going to use are going to be these steps. There's actually only 3. The first step when we're going backwards is to find our ions. And in doing that, we are going to check the periodic table and assign charge. All 3 of these steps are going to happen at once. Let's talk about what that looks like, right? I see calcium bromide. Okay, that doesn't really give me a whole lot, so I'm going to try to look at the periodic table. I'm going to find calcium. Bromide came from bromine. So I'm going to find calcium and bromine and see what they tell me. All right, so we take a look at the periodic table. Here is our periodic table. Calcium is right here, Ca. And we look at the periodic table, we look at the charge it has a +2. So we're going to translate that over. We've got Ca +2. What about bromide, which comes from bromine? So let's find bromine. All the way over here, bromine has a -1, a +1, and a +5. How am I ever going to choose the correct one of these 3 things? Well, I look at my formula here, and I think to myself, the first ion is always positive, the second ion is always negative, so bromine must have a negative charge in this situation. Look, bromine only has one option for a negative charge, so we have to use bromine -1. And by doing this, by checking the periodic table and finding my ions, I have checked the periodic table and I have assigned my charge. So I have done all of these steps in one. Which means now I'm going to crisscross. So let's take what we have and bring it down. Right? Ca +2 Br -1. Now, when we crisscrossed from formula to name, we took them from the bottom and we brought them up. If we are going to crisscross now to go from name to formula, I'm going to take these numbers from the top and bring them down. And that's going to bring me to my final step, where I see Ca1, Br2. The final step is to reduce. You must reduce these numbers if possible. Can I reduce a 1 and a 2? Can I make these any smaller than they are? And the answer is no, right? I cannot make these any smaller than they already are. The 1 is optional, so I can just erase that if I want. But it's not incorrect to leave it there. And so my answer is CaBr2. Done. Here we're just finding our ions, crisscrossing, and reducing. Alright, let's look at some other examples here. This one has a Roman numeral. When there's a Roman numeral, we already know the charge of the positive ion, because that's what the Roman numeral is there to represent, right? The Roman numeral tells us what the charge of the positive ion is. So without even needing to check the periodic table, I have iron 3, that's going to be Fe plus 3, because this Roman numeral is equal to this charge. Always, always, always. But then I've got nitrate. Now, nitrate is a little funny. It does not end in "ide." Right? Bromine becomes bromide. Sulfur becomes sulfide. Nitrogen becomes nitrate? That's not right. Things that don't end in "ide" are polyatomic ions. So this polyatomic ion must be on table E. And so we're going to take a peek over at table E and see if we find anything called nitrate. And we look and we look and we look and we look. Here it is. Nitrate is NO3 minus. NO3 minus. We're going to put it in parentheses because it is a polyatomic ion. We don't want to make any mistakes with that. And I've already now found my ions, checked the periodic table, and assigned a charge. And so we're going to bring it down to the crisscross part. Fe plus 3, NO3 minus 1. We're going to bring our numbers down. The 3 is going to go down and over to the nitrate. The 1 is going to go down and over to the iron. I'm going to draw a better arrow there. And then we're going to have Fe1, NO3, 3. My last step is to reduce the numbers I crisscrossed. Is there any way to reduce a 1 and a 3? No. Right? 1 and 3 can't be simplified any further, and so my final answer looks exactly like this. Again, these 1s are optional. You don't always need to include 1s. It's the only thing you don't have to write. Now I hear you, you're saying, Mr. M, we haven't reduced yet. Are you just going to show us a bunch of examples where we never reduce? That's not very responsible of you. And I will say, hold your horses, because here we go. Look at this, barium sulfide. We're going to have to reduce this one. We're going to start by checking the periodic table, finding our ions. Barium sulfide came from sulfur, so we're going to look for barium and sulfur. Check the periodic table for this one. Barium is all the way over here. It only has one possible charge, so we're going to put Ba plus 2 for our barium. And then we've got sulfide, which came from sulfur. So we're going to take a peek over here, looking for sulfur. Oh, we see that same problem we saw before. Sulfur has 3 different charges. But we know that it's the second ion in the group, right? Second ion in the compound. And so we should have a negative charge on our sulfur. So S minus 2. So far so good, right? We've found our ions, and in doing so we have checked the periodic table and assigned charge. And so we are going to bring those over to our crisscross step. Ba plus 2S minus 2. And we are going to crisscross those 2's down and over to the opposite ion. And then we are right here, Ba2S2. And I asked the same question I asked every other final step. Can I reduce the numbers that I have crisscrossed? And here the answer is yes. Yes, I can. A 2 and a 2 can be reduced and be a 1 and a 1. So here, I'm not actually done yet. I must reduce. I must reduce if I can reduce. So these are going to go away. The 2's are going to become 1's. And then, like I've said, the 1's are optional. So this can be Ba1S1 or just BAS. But you must reduce this. Now, I'm going to ask you to take a stab at aluminum phosphate. Take about a minute and a half, and then we will go over aluminum phosphate. aluminum phosphate. Let's take a look at this together. Aluminum phosphate. I know aluminum's on the periodic table, where phosphate, right, the fact that it ends in not-ide, clues me in that this is a polyatomic ion, and I should look at table E. And so I go and I look at those places. Aluminum, right here, Al, with a charge of positive 3. Alright, so far so good. I write Al plus 3. For phosphate, I need to check table E, see if I could find it on here. Looking at the rows carefully, here we go. Phosphate is PO4 with a negative 3 charge. I'm going to put it in parentheses from the start just to be safe. Just to make sure I don't mess with the numbers that are in there. And I have found my ions, checked the periodic table, and assigned charge. And so we move on and we look at our crisscross step. I've got Al plus 3, PO4 minus 3. Make sure I keep that in parentheses. I'm going to now crisscross. I'm going to take this 3 and move it down to the phosphate, and take this 3 from the phosphate and move it down to the aluminum. Bringing me to my last step, my little cleanup step. I got Al3, PO4, 3. And now I ask the question, can I reduce a 3 and a 3? Yes, I can simplify those. I can make that a 1 and a 1. And since I can reduce, I must reduce. So my 3's become 1's. Now, the final cleanup thing, right? Like I've said, 1's are optional. You can actually write this as just AlPO4. Because there's an optional number outside of the parentheses, you actually don't need the parentheses or the 1's that are here. And so for a lot of those compounds that we looked at already with polyatomic ions that don't start with parentheses, right, the ones that we have to find the polyatomic ion and then put it in parentheses during our assign 1's step when we're doing the reverse, it's because of this reduction. When we reduce down and we have 1's that we don't need to write, these parentheses also become optional. Let's put the optional stuff in red here. You're not necessarily wrong for including those parentheses, but they are optional parentheses. In this situation, because there's no number that needs to be outside. Here, in iron nitrate, we do need these parentheses, because if I take this parenthesis away, I now have iron, 1 nitrogen, and 33 oxygens? That's definitely not correct. Right, this number when it crisscrosses is telling me I need 3 copies of NO3. And so these parentheses are not optional. These must be there, otherwise they're going to really confuse these two different 3's and make them look like a 33. Now I do have a bunch more practice problems, and so I'm going to put up all of these practice problems for us to practice with. Pick 1 or 2 and give them a shot. I'm going to give about a minute and a half. And then I'm going to reveal the answers. Again, if you want to do more, please feel free to pause the video. or if you're coming back to watch this after the fact, right, after we've done this lesson live, just pause the video now and take your time and work on all of them. When these names are correctly transformed into formulas, we should end up with these formulas. Some of them needed to be reduced, some of them are polyatomic ions, some of them can't be reduced, some of them are just ones from the start. Right? There's all sorts of different things that we can do here. But as long as you are carefully paying attention and looking at the periodic table when you find your ions, you're reducing when you can, you're putting polyatomic ions in parentheses from the start just in case, you're going to be in good shape. And now I'm going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.